Thank you. Good to see you. So we'll talk a little bit more about germline. We've already started talking about germline, as Gustavo alluded to in the last case with an MUTYH suggested germline mutation. And actually, if you notice, the first case had an MUTYH suggested germline mutation too. So for this case, this is a patient that I've seen at the University of North Carolina. And I will also, there we go. She's a 28-year-old female with a past medical history of PCOS, not other medical history, presenting with a white blood cell count of 293,000, 93% of which were lymphoblasts on peripheral smear, without evidence of leukostasis or other complications. Notably, her family history showed that both grandfathers had had pancreatic cancer and her maternal grandmother had had ovarian and breast cancer. Her flow cytometry confirmed B-cell ALL with positive expression of CD10, CD19, CD34, which was variable, TDT, CD22, CD38, and HLA-DR. Our preliminary FISH and cytos showed a rearrangement of chromosomes 4 and 11, which is a concern for a higher risk B-cell ALL, and that is when we sent for the GTC expression panel.
Okay, so what we found in this patient, actually, we found germline mutation, as you can really see them here. And for all practical purposes, there's no classification for them, so they are both, at this time, variant of unknown significance. But we detected actually the 411 translocation, which is frequently associated with acute lymphoblastic leukemia, in addition to a second chromosomal translocations that involve the CXCR4 with the MIP genes. There were no mutation, actually, and no detectable chromosomal abnormalities, but there was demonstrable clonality for the heavy chains, for the immunoglobulin heavy chains, and there was no clonality for T cells. So if we look actually at the markers, as you can see here, and again, we do practically flow cytometry by RNA, and CD19, as you can really see it here, practically high as compared to normals, as I put here 3 different types of normals. And so there is CD19 high and CD22 relatively high. Now, there's a very important point here. If you look at the ratio between CD19 and 22, in general, in normal lymphocytes, always CD22 is higher than CD19s, as you can really see here in normals. You can see CD22 is higher than CD19s in normal, but even if you take lymph nodes, you take proliferations, if you take diffuse large B-cell lymphoma, it is always CD22 is higher than CD19, except in acute lymphoblastic leukemia, and for some reason, CLL as well. So practically when we see inverted ratio of CD19 to 22, we always start thinking about either CLL or ALL. So these are part of the refined things you do or you get when you look at the RNA expression, because it allows us to quantify significantly better than flow cytometry. But more important, you want to look at CD34, and this is where you say this is not CLL, this is ALL. You look at, of course, CD79A is high, and more importantly, you want to look at the TDT, and TDT is also very high. So this is definitely acute lymphoblastic leukemia as a diagnosis, but you can really look at the clonalities. Now, we define clonalities actually by the ratio of the highest expressed clone to the second highest expressed clone to be tenfold higher. And as the day go on, I'll explain to you on what basis we came up with the tenfold higher. So as you can imagine, the expression of the immunoglobulin relatively low if you compare this, which I will show you later, let me say, with multiple myeloma, where the expression is very high. And as you all know, usually the acute lymphoblastic leukemia does not really express much of surface immunoglobulin, and most of the time it is cytoplasmic. But we don't see clonality for the kappa or for the lambdas, as you can really see it here. And the overall expression fairly very low. Now, definitely this is a fusion that we see, which is 411 fusions. So the KIMT2A is fused with the AFF1 genes. And this is the second translocations between the CXCR4 with the MIP genes, and both actually practically bad. But KIM2 fusion is supposed to lead to overexpression of the HOX9. So as you all know, for menin inhibitors, it is very important for menin inhibitor to work that HOXA9 should be very high, because frankly, that's what drives the cancer, and this is how menin inhibitors will work. So here I'm showing you actually data on our acute myeloid leukemias, shown here in the blue, and the acute lymphoblastic leukemia shown here in the orange colors. And they are the expression levels in acute myeloid leukemia is actually ranked from the highest to the lowest. So here, as you can really see, almost 721 cases of AML, but I must say the acute lymphoblastic leukemia is only about 200 cases here. And overall, there is, in acute lymphoblastic leukemia, less expression. This particular case, the expression in acute lymphoblastic leukemia is around 531, which is, it's still high, and most likely, that reflecting that this patient might really respond to menin inhibitors, because I will show you later on examples where the level is lower than this. But now to address the questions that Dr. Williams really raised, the patient has family history of predisposition to cancer. So the patient has these two mutations in these two genes. Both mutations lead to early termination, as you can really see here, termination. So practically, it is not the full protein expressed, it is a portion of it expressed. The two genes are Blair Wall. The first one, the NOD1, actually it is relevant for triggering or as transacting factors for inflammatory mediator genes and chemokine and cytokines expressions, but there is no real, even in transgenic mice or knockout mice, it is not lethal. Still, the mice, survive, but their major problem is inflammatory rather than cancer development. In contrast, the PCMA1 is genes involved in the centrosomal protein structures, and knockout mice is not lethal, but they have tendency to develop cancer. And as a matter of fact, we see mutations in some types of cancers, as well as in PCMA JAK2 fusion, we see it in TLL. But overall, both genes very weak as predisposition to cancer. However, the combination of the two genes might be relevant. So as you all know, currently the concept of polygenic risk factors is growing, and we know that multiple factors or multiple inherited trends can add to each other and make a person more susceptible for developing cancer, not only one genes like the BRCA1 or other genes that we know they are pathogenic and increase the predisposition to cancer. But this is from a study actually where it shows that you can really have this is in breast cancer studies, and you can really have family history. Actually, it adds significantly. And as a matter of fact, if you look at these graphs on the top here, family history plays a major role in deciding whether a patient can have higher incidence of cancer, irrespective of the polygenic score factors and irrespective whether that patient has specific pathogenic mutation or not. But the most powerful thing is that when you combine, whether you are combining, as you can really see here, like family history with polygenics or even mutation with history, the factor become the strongest when you combine multiple factors here for inheritance. But this goes back into the complexity of inheriting cancers and how it varies from one person to the other.